Hi, my name is Matias Lama and I'm going to talk about the Arduino. What is Arduino? Arduino is an open electronic platform for the creation of prototypes based on flexible and easy to use software and hardware. It was created for artists, designers, amateurs, and anyone interested in creating environments or interactive objects. Here's a video.
What is the Arduino? The Arduino is a microcontroller that's great for hardware prototyping. Essentially, a microcontroller is almost like a brain of sorts. So it processes inputs and then sends out outputs. You can think of this like a human body, where your brain processes inputs like things you might see and then has an output like something you might say. Just like that, with the Arduino, you can control circuits, LEDs, the sky's the limits. The community online is incredibly active, and here are some examples of things you can make. The possibilities are endless with prototyping hardware with the Arduino. It has a low barrier to entry and a really high ceiling, so to get started, just check the notes below for some beginner projects and some resources.
Now, continuing. What can an Arduino do? Arduino can feel the environment, receiving signals from a variety of sources, of sensors, and can affect their surroundings by controlling various actuators such as light, motors, etc. So here are some examples of what an Arduino can do. Mini car, you can control it. Smiley face with LED, more LED controlling systems, maybe a bar, the inverter it's called. And here's another video. Sorry. Next, how does it do it? How the Arduino works? Well, the microcontroller on the board is programmed through the Arduino programming environment based on C++. The microcontroller is the brain of the plate. Without the microcontroller, then the Arduino obviously won't work.
Have you heard of the Arduino and are wondering what it is? We use the Arduino a lot in our projects at Make. Due to its popularity and ease of use, it's one of our favorite microcontrollers. In fact, we dedicated an entire issue to it. But if you're not even sure what a microcontroller is, this video has you covered. A microcontroller is a circuit board that has a chip on it that can be programmed to do many different things. You can read information from sensors. For instance, if you want the board to read how bright it is in a room, you can use this photoresistor, which is sensitive to light. Or you could detect when someone walks into a room with this motion sensor. Even this GPS receiver is a sensor. It tells your project where on the globe it is. Now, that's just a small sample of the different kinds of input that sensors provide, but what can you do with that data? Using output, you can control devices or display and store data. For instance, you can have your Arduino simply blink an LED like this. For something a bit more useful, you can hook it up to this product, called the power switch tail. It lets you control the power to your AC devices, like your lamps and appliances. This LCD readout will let your Arduino display text information, and you can also have sensor values go right into your computer for storing or processing. We're just scratching the surface of the different inputs and outputs that we can use with the Arduino. There's just way too much out there to cover in a single video. But let's take a look at how an Arduino can play a role in a basic project. Let's say you want your living room lights to turn off when you press play on your DVR or DVD player's remote so that you can enjoy your movie in the dark automatically. To make this happen, we'll need a sensor that can read the light that comes out of the remote control. It looks like this, and it's called an infrared sensor. And how do we turn off the lights? We use the power switch tail I mentioned before. It plugs into your wall, and you plug your lamp into it. This wire is what we'll use to control the power switch inside. So how do these work together? Well, that's where the Arduino comes in. We'll hook both of them up to the Arduino pins and write some code to upload to the board using free software. In a very basic overview, the code that we upload to the Arduino will be checking to see if the sensor has received any pulses of infrared light from the remote. If the pattern of flashes matches the pattern of flashes we know to be for play, the Arduino will send the signal to the power switch tail to cut the power to the lamps. We could then enhance this project so that when we hit stop or pause, the lights turn back on. It's just a matter of updating the code and uploading it to the board. You can reprogram these boards over and over again. There's so much you can do with the Arduino, it's kind of incredible. I used infrared for my Enough Already project, which listened to the closed captioning track from the TV and would mute the TV whenever someone was mentioned that I didn't want to hear about. Here are a few other ideas of cool things you can do with the Arduino. Randy Serafan created the lunchtime clock, which speeds up slightly right before noon, slows down between 12 and 1, and then speeds up again, giving you 12 extra minutes of lunch every day. Steve Hofer's Secret Knock gumball machine was featured in Make Volume 25. It's a lot like a regular gumball machine, except that instead of a quarter, you need to know the secret knock to get a gumball out. The Arduino also lets you take your projects online. Even your cat can start tweeting with the Kitty Tweety project from Mark DeVink. When your cat plays with a little toy, the device tweets. The project can be found in Make Volume 22. And who doesn't love a robot? Arduino can help you make your own. It acts like the brains of your bot. But what if you want to use your brain to control the bot? Check out this mind-controlled Arduino robot from Tero and Kimmo Karvinen. It can be found in our book, Arduino Bots and Gadgets. So that's just a small sample of what you can do with an Arduino. My best advice to you is to jump right in and start playing around. The Maker Shed offers these great getting started with Arduino kits that have everything you need to start exploring the possibilities. And if you're looking for inspiration, it's not far.
Moving on, we have what are the applications of the Arduino in medicine? Well, the Arduino can be used in multiple ways in medicine. We can use it as a monitor for the ECG and respiration. We can use it as a crying baby detector, a cardiac monitoring system, health band for the assistance of the elderly, sleep quality monitor, and e-health sensor monitor. We are gonna see a video where it explains what is an e-health sensor monitor and how it works, basically.
Hi there, I'm Luis Martin, electronic engineer in Cooking Hacks, the open hardware division of Libero. I'm also one of the co-founders of Zaragoza Hackerspace, the LAS. It gives makers, artists, hackers, and other people a place to meet and develop their ideas. As an open source enthusiast, I've developed several projects related to infrared technology, 3D printing, or industrial protocols. Today, I'm going to talk about my last design, e-health sensor platform. Most of the medical market solutions have prohibitive prices and proprietary license, which make it possible for community to develop applications with them. This project provides a cheap and open source alternative. The e-health sensor platform has been designed in order to help research developers and artists to measure biometric sensor data for experimentation, fun, or test purposes. This platform allows Arduino and Raspberry Pi users to perform biometric and medical applications using different sensors. Pulse sensor to measure the heart rate. Oxygen sensor to know the amount of oxygen in blood. Airflow to measure the breathing rate. Body temperature to measure the skin temperature. Electrocardiogram to see how the heart rate is. Glucometer to know the level of sugar in blood. Galvanic skin response to measure the sweating of the skin. Blood pressure to get the systolic and diastolic values. And patient position by using an accelerometer and measuring the change in the three axes. The information gathered by this sensor can be used to monitor in real time the state of a patient. We made the e-health shell to be compatible with both Arduino and Raspberry Pi, as we love both platforms. As an example of use, I am going to connect the pulse and oxygen in blood sensor. First, connect the cells over Arduino and plug the sensor. Then just insert the finger and press the on button. After a few seconds, we will get the values in the LCD and in the computer. Once we get the data stream, can set alarms to monitor if we are above or below a certain threshold. Let's see also how to connect the electrocardiogram sensors. Just remove the plastic protection and connect the electrodes to the skin. The monitoring program in the computer shows the electrical activity of the heart muscles. Data can be also sent to the cloud, allowing multiple real-time visualization systems. In this case, we use a mobile app designed to easily see the passing information. Using the Wi-Fi radio module, we can connect to Arduino to our Wi-Fi access point to send the sensor data. Let's use the airflow sensor to measure the breathing rate in a patient. As we see the mobile application, so the sensor data gathered in real time. With this platform, we want to give the community the necessary tools to develop new e-health applications as the basis of a new era of open source medical products. Thank you for listening. I hope you join us.
Now, continuing with the exposition, we can conclude, or with the conclusion, that the Arduino is a small device that can be used in multiple activities, medicine being one of them. That is why we need to be aware that this type of system exists in order to apply them into our professional environment. Here's another Arduino used in medicine.
This is a meditation reminder using Arduino Uno. You can see the time over here. We can set the time interval to take pills by setting this button, and set time interval I am setting to 1 minute now. So you will can see time to take pill tray number 1. So LED 1 nothing but a tray number 1 is blinking and it goes off, and buzzer indication also gives. So we wait for another minute. It will show the first tray. Sorry, it is already shown first tray. Now it is showing tray number 2, and LED number 2 is blink. The RTC DS1307 over here, and this is Arduino Uno. This is buzzer, and this is increment and decrement and set button. This is 16 into 2 character LCD display. If you like this project, please subscribe our channel and hit the bell button for more future uploads. Thank you.
And thank you so much for your attention.